Hello, it's Carly McAvoy. I'm talking about rounding significant digits. I did this video once and then I had some audio troubles. So I'm just going to read through it again. I've already got the answers written in. The precision of an instrument is the placement of the last significant digit to the right, or the precision of your measurement. For instance, if we have a precision that's 1/1000th of an inch and you multiply two dimensions together, would you get an answer with the precision to the 1/1000th of an inch? Well, when you try it, you can see what happens. This has a precision to the 1/1000th, this has a precision to the 1/1000th, but your answer is not to the 1/1000th if you do it on your calculator. And so we have an answer that appears to have a precision to the 100,000th inch, or inches squared, if we're talking about that problem. But our answer can only be as precise as the values we used in the problems. So we need to round our answer. So write down what number you think you should be using as your answer, and that is round your answer to the correct number to the correct precision, which is going to be, where's that last significant digit? Well, we were going to the thousands, so it should be 39,231 and 842 thousandths. Why 42? Because here is our our 100,000ths place, thousandths place, excuse me. And if we look one to the right, that's 5, so we would round that up to a 2. You can't just drop the numbers, you have to round them correctly. If you're working with values of varying degrees of precision, your answer should only be as precise as the least precise measurement. So what would the final answer be to this problem? And I already have it shown actually. But if you had 14 and 985 thousandths and you added 16 and 1/10, first you would get 31 and 85 thousandths. But what should your answer be here? Well, your answer should be 31.1, because you can't be any more precise than that least precise one. And the least precise one we had was 1/10. Therefore, that 0 looking one to the right is going to become a 1, and that's where we'd have to leave it. Okay, remember that accuracy refers to the number of significant digits that you have. If you were told to round this number to have 7 significant digits, what would the answer be? Well, we have right now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 significant digits, so we only want 7. Remember, every non-zero digit is significant, so there's 10 significant digits. We would knock off these last 3. And now, here would be our 7th one. And if you look to the right, that's a 1, so we would not round that up. So it would just be 53,231 and 84 hundredths. That's an accuracy thing. That's not saying to round that to be precise, but rather to be accurate. Accuracy has to do with the number of significant digits, and precision has to do with where the last significant digit is. And sometimes those look very the same, and sometimes they don't. Okay, so let's look at this first problem set that I have. Again, I filled it out already, so I'm kind of just hiding it. Round this to 5 significant digits. That's talking about accuracy. Or change the precision to be 1/100th. Well, right now we have a precision to the thousandths, and we have 6 significant digits. So in order to make 5, we would just 1, 2, 3, 4, 5. That's where we're going to end at. But what happens when you have 59? It actually rounds up to 60. And so we're going to end up with 124.46. Because we want 5 significant digits, that's where we're going to stop. But that number also happens to have a precision to the hundredth, right? Because it goes exactly to 2 places out. So that's the same in that case. Would it be the same here? Well, 5 significant digits would be 1, 2, 3, 4, 5. And therefore, we would have 0.3. 0.3 would be a precision of 1/10, and we want to have 1/100th. So how would you write the precision of this to make sure that it goes out to the hundredths? What you'd have to do is add a 0. So this has 5 significant digits. This has a precision to the 1/100th. By putting a 0 on the end, that gives us a precise number. Remember, zeros are significant if they're to the right of the decimal place and to the right of a significant digit. So what about this one? Well, I could wait for a second. 5 significant digits. I have 3, and I need 2 more. This first one is not significant because it's in front of the whole mess there. And so in order to make that have 5 significant digits, I would add 2 zeros to the end. And that would give me 5 significant. Remember, these are going to be significant. They're to the right of significant digits and to the decimal point. This one, though, to a precision of 100ths, we just want to round it to the hundredths place, and so that would become 0.22. So very different looking at the end, where they looked this similar as we started. What about 3 significant digits? You should try these 3. I'm hiding the answers. You should try these. We want to round to 3 significant digits, and we want to change the precision to be 10. Well, this to 3 significant digits, 1, 2, 3, we want to stop right there, and then we want to round that, so we'd get 9,260. We would not put these on, because if we trail zeros after the decimal, they're significant. So we would not put that. But to have a precision of 10 is the same. That's supposed to be a 6. It's the same, right? Because what we're seeing is that we have, this has got 3 significant digits. This is not considered significant because it's not following a decimal point, and it's not sandwiched in between 2 significant digits. This has a precision of 10 because that's what the number is right here. So those are the same again. What about this one? Well, 459, 600, in order to round that to 3 significant digits, we want to round right here to that 9. But look one to the right, and that's a 6. That rounds that 49 up to 50. And now in order to show that that's significant, we need to put a bar above it, because trailing zeros when there's no decimal involved are not significant. We have to mark it in some way to make it significant. And then changing to a precision of 10, well, we want to make that 10 our most significant, or our rightmost significant digit. And so in order to do that, I'm just going to take my number and put a bar over it. So that looks pretty different. This has a significance of 10. This has 3 significant digits, or this has a precision of 10, sorry. And then the last one, 3 significant digits, 19.0. And I don't have to, the 0 is significant here. It's sandwiched in between 2 numbers. It's following the decimal point and following a number. There's a number of reasons how we can see that that's significant. So that would be our answer, 19.0. That's 3 significant digits. On the other hand, a precision of 10, we're going to look to the tens place right here. And that 119 is going to round up to 20. And so we're going to have a precision of 20. This tens place is our last significant digit. That's perfect. And finally, the last set, and again, you might want to try these on your own and then come back, is what would be 2 significant digits here, and what would be the precision to 1,000ths. Well, 2 significant digits, I'm going to go 1, 2, and I'm going to round to this up. 49 is going to become 50. And so I'm going to have 150,000. How would you make this precise to the thousandths? Well, you've got 1 decimal place, you're going to add 2 more. So we have 150,000, excuse me, and then we have just 2 more zeros on the end. Again, why didn't I put tags over those? Because they are already significant, because they're following the decimal point and they're following a significant digit. That makes them significant. This one would not be significant because it's not following a decimal point, so we have to tag it to show that it is. Round to 2 significant digits here, we're going to go to 15 and then drop everything else. To change to a precision of 1,000ths, we're going to go right here, we're going to round up, and we're going to have the 15.350. If it's asking you to have a precision to the 3rd decimal place, you have to put a 0 there if nothing else is there to show that that's how precise you want it to be. And finally, for the last one, 0.04397, rounding to 2 significant digits, we have this is not significant and this is not significant. They neither one are. 2 significant digits here would be 4, and then that 3, which is followed by a 9, so it would round up to be 0.044. And that's the exact same precision we would get for 1,000ths, because that's going out to 3 places. So those 2 would be exactly the same, and the other 2 look pretty different. So rounding to significant digits and rounding to precision are 2 different things that could come out to be the same, or they could come out just to be very different. All right, have a fantastic day.